When we look at applications of parabolas, we've studied some in previous classes where we looked at the idea of parabolic motion when you throw something. And if you remember, we measured the height of an object is equal to -1/2 g t squared plus v naught t plus h naught here, where we had this would be the initial height. This is the initial velocity. This is the time it takes the object to travel, etc. And this is the gravity constant. Another example of a parabolic application is the idea of parabolic mirrors. These parabolic mirrors, if you consider a light emanating from the focus, that light then reflects off the parabola and travels parallel to the symmetry of that focus. The light can then reflect to that axis of symmetry, and that property is used to help us build things like searchlights. Headlights also employ this idea. So let's look at an example of how we might do some calculations about this. If we consider a type of telescope, there's a telescope called the Hale telescope, and it is a parabola that has a cylindrical top surface that might look something like this if we look at it from the side. That cylinder is 200 inches in diameter. So if I split this in half and consider this the point 0, 0, then it's going to go out to 100, 0 here, and out to -100, 0 here, because remember, the diameter is 200. Along the outer rim, the cylinder is 26.8 inches thick, and in the center, it's 23 inches thick. So it gets deeper as it travels out. So we have something that looks a little bit like this, and as you can see, it is a parabola. Now, the distance here, the difference is 26.8 and 23. So this distance right here is 3.8 inches, giving us a value here of 100, 3.8, and -100, 3.8. If we want to determine an equation for this parabola, we know that it is a vertical parabola. So we're going to have x squared. Notice our vertex is 0, 0, so we don't need to worry about h and k, is equal to 4p times y. Well, we need to be able to figure out this 4p value. Because we already know several of the points that are on the parabola, we can plug those in. So for example, if we take this point right here, we know that x is 100, so 100 squared is equal to 4 times p times the y value, which is 3.8. We square 100 and we get 10,000 is equal to 4 times the 3.8 gives us 15.2 p, and then dividing both sides by the 15.2, we get that p is equal to 657.9 inches, or p is about 54.8 feet. And then from this, we can determine where that focus is in terms of the setup for the parabolic mirror. That distance p has to be equal distance from both the focus and the directrix.